Okay, it's 9 o'clock in the morning. Let's get started. Um, Good morning, everyone. Welcome to Shenzhen and welcome to the LSR session. I'm Yingzhen Qu and I have my co-chair AC and Chris online joining me remotely. So we have a relatively light agenda, so let's get started. Oh, okay. We don't have volunteers for the note taking. So for people who speak or make comments at the mic, make sure you check the notes to, and make sure your comments get recorded. Okay, so let's start with the working group status. Maybe I should start to this. Okay, how about this mic? Can you guys hear me okay from this mic? It's for remote people.
Yes. Yeah, it
Okay.
sounds good.
Yep.
Okay, yes, want to make sure this mic works well. So it's Monday morning, so we need to look at the note well. It's basically saying by participating in the IETF, you are agreeing to follow the IETF process, behave well, be polite, and if there are pointers in the slides, if you are interested in that, you should read the detail. And if there is any question, talk to the chairs, talk to the AD. And especially for people in this room, make sure you sign in using your phone. So then you can join the queue, ask questions, and we will also record the right number of participants for the session. And we don't have any volunteer for the note, so I also sent a link in the chat, so please make sure you help with the note taking. We have 4 RFCs published since IETF 124. We have 2 data model, both for OSPF and ISS segment routing, finally published. And also the ICP and reachable prefix announcement. That one has gone through a long history. And we have Anycast property advertisement on RFC editor queue right now. So this one hopefully will be published soon. And these 3 drafts have been submitted to IESG for publication. The link infinity, there was a discussion from the IESG, and the authors have cleared the discussion. So the draft is ready to move forward. Yeah, okay. And hopefully move to the RFC editor queue anytime soon, right? And the Flex Algo Young model are now in Gunter's hand, pending for AD evaluations. You want to say something?
Just a quick update. So the first one, the link infinity, is pushed to RFC editor right now. So that's a good thing. And the other 2 are on the agenda for the next telechat.
And we adopted the flooding reduction algorithm framework. And Tony P is gonna give an update on this today. And Tony Lee, we actually have a question for you about this draft. I think it jumped between informational, experimental. So
We would love to move it forward. We don't care whether it's experimental or informational. Doesn't matter.
I think there are some new requirements for a draft to be experimental. Is that correct? Yeah. I haven't looked in.
So Gunter speaking here, routing ID. I wouldn't really require, call it like new requirements. The a more modern philosophy, let me call it like that, is that in the IFG there is this belief that an experiment should be an experiment as such. So it's still being debated to some degree on what experimental actually means. So yeah. So typically an experiment, there's like a start date, an end date, and a particular target. So yeah, that is where we are right now.
Yeah.
Okay, well, we have a start date. We've already shipped the code. We have an end date of never because we've shipped the code. We're not going to stop shipping it. Um, so, if you don't want to call that an experiment, then I guess we'd like it to be informational.
I think I forgot, you started from experimental, right? Or you
Yeah,
start
I
from
think
and
I
then you
believe that it switched to info.
you change the track in between when
To info.
it was adopted by the working group. I don't know whether it was a mistake or you intentionally did that.
Doesn't matter. We don't care what it is, what would help it move forward. We don't want to have an argument. There's no point in the argument.
Okay.
Tony, it wasn't an argument. We just wanted to make sure that you were aware that it changed.
Yeah.
We don't have a problem with how either way, and we'll move it forward.
We just
Thank you.
want
Let's just move forward. That's all that matters.
we just want to make sure it was not a mistake. It was your intentionally change the status, the track.
I probably changed it because somebody asked me to.
Yeah, 'cause
I just say that if you follow the precedents that has been set for other drafts that have been implemented by a uh, single source, we've made those experimental in the past. I don't know about these new requirements for defining the experiment and the outcome and everything like that, but
Yeah, so Gunter again here. So from my perspective, I think both of them are good. So I'm very pragmatic. They will both help. To me personally, I think experimental is probably more close to the intention here, I guess. So I'm happy with that. If that causes problems, then I will handle them at that point in time with the IGSG.
yeah,
I think the most important thing is to
the
put
chairs had a discussion about this draft and we thought it was experimental. Then we noticed the track changed in between. So we just want to check with Tony, make sure we are on the right track. Yeah.
I will happily change it back at the drop of a hat. Just let me know what you want.
Okay. And we have two drafts that's in the adoption queue. So I think the authors have requested adoption call. So we probably will start the process after this IETF. If people have any comments or want to review it, please do.
So this thing is really low, eh? Voila, better. So one thing what I've been noticing also with the current IESG, they're like much more rigid on what is in charter and outside of charter. And what we have seen so far is that uh, so one of the things I think what we have in LSR, if we have a document which is like maintenance, that there should be a milestone in there. So we probably, if we are thinking about adopting them and you're adopted, we should actually add a milestone in there to avoid troubles down the line.
How about we do this? If we are ready to adopt something, we put it in the milestone. Otherwise, just individual documents, then we just let it sit there. Yeah, we need to remember to do that.
I think we can do it upon adoption.
Right. Yeah, that's just one actual
Yeah,
step
yeah,
for the
yeah.
adoption.
Once it's adopted, we don't need it at the start of adoption.
Yeah, I'm wondering how many years have we been running this working group, and we almost never use milestones, and we don't worry too much about this chart. I just love all the process that's suddenly showing up.
Well, yes.
Well, it's just one small extra step, so not that big deal. And there are a bunch of young models in the working group. I will do a presentation later about this. So,
Welcome to ISO.
and these are the existing working group document. And I think the first one is close to be ready to last call. The authors have communicated with the chairs that they will probably make one more version of changes and ready to last call it. And the last one, the multi-topology for segment routing. That one has dependency on those two drafts. And one of them is ready to be published. The other one is just an individual Spring Working Group. It's just a Spring Working Group document. So we'll just have them sit there and wait. And that's today's agenda. Any comments about agenda? Any changes we need to make? If not, Leah, you are the next one. Any comments about the working group?
Good morning, everyone. I'm Lian from China Mobile. I'm on site for the first time, so nice to meet you too. And sorry, we wait for the
My
slides.
screen shows we have a little problem. I think my meter echo crashed. What's wrong?
John, are you able to get back to it, or do you want me to try to display the slides?
Give me a second. Let me try. Yeah.
Yeah, okay.
I think my meet. You can still see the screen, but my browser already crashed. The echo session crashed.
Yes, we see the agenda slide.
Oh, no, okay, thank you, Yingzhen. And it's great honor to be here to present our draft on behalf of all the co-authors. And our draft name is the Advertisement of Remote Interface Identifiers for Layer 2 bundle members. And first, I want to go overview of this document, and it describes how the OSPF and the ISS would advertise the remote interface identifiers for L2 bundle members. And the key purpose is to enable the controller to know which interface on one side connected to the which interface on the other side for the topology management or traffic engineering scenarios. And the initial document was presented at the IETF 119 meeting about March 2024. And it became a working group document since March 2025. And we have updated 2 versions based on the discussion from the mailing list and also the meeting discussion. So today I will present all the updates about these 2 versions. The first one, we clarified the use case description, and we add some text to describe the traffic engineering and bidirectional path computation scenarios. And the second one, we improve the BPL's specification by adding the explicitly reference about the peer agency link from RFC 1986. We think that this extension makes it more clear and more consistent with the current protocol. And the third one, we completed the security considerations, add some comprehensive security tests, including OSPF, ISS, and also BPLS. And overall, this document doesn't propose new security issues. So all the current solution for these protocols is applicable. The fourth one is about how the remote identifier is acquired. As we all know that IDP have no direct way to exchange the L2 bundle member link identifiers. So we rely on the L2 protocols. And how to acquire it is up to the range of our draft, but we gave 2 proposals and all some advice. The first one is the like bundle protocol, and the other one is the LLDP. And the LLDP runs on the physical links to change the neighbor information, and the port ID TLV can carry this remote ID. So in previous version, we mentioned the management address TLV, and it was not correct. So it was a mistake. So we corrected it, and now it points to the port ID TLV, which is mandatory for the LLDP. And finally, we update the INA consideration, adding the MP field to align with the ISS protocol. And this all the update of this draft. We think now it's more mature, and we are ready to the WT last call. And always welcome the comments and suggestion at any time. Thank you.
Jeff, please go ahead.
Sure, can you hear me? Try again, can you hear me?
Yes.
Yes.
Thank you for comparing. Leanne, thank you for the presentation. I see your primary mechanism is LACP. Has there been any discussion about BFD for lags?
BFD?
Yes, so LACP is one way that lags can be formed with different port IDs. Another common way for doing this type of lag is using BFD.
But I don't think it's related to the BFD protocol because we just get the remote ID identifier to address to in IGP so that the BPLs can gather it for the controller. So I didn't catch your why it's related to the BFD protocol.
So Jeff, my understanding is you are suggesting that's a possible solution to get the remote ID, right?
I'm suggesting that LACP is the most common way that these types
Yeah,
of
but
flags are.
BFD is another possible way. Right?
Exactly. And
Okay.
since this is an
Okay.
IEEE versus IETF
Thank you,
model.
Yeah,
Imogen.
I think
I understand.
that Lian can work with you offline as
Yeah.
if that's another possible candidate solution for that part. But that is actually clearly out of scope of this document. It's just some suggestions. Yeah, but anyway, yeah.
Yeah, we can discuss offline and maybe we can, if it's suitable for the proposal, we can add it to the draft.
Sure. Les, you are the next.
Thank you.
Yeah, and, I just wanted to reinforce. Frankly, Jeff's comment confused me. I really don't see what BFD has to do with this draft, but maybe he can enlighten. Thanks.
Okay. Yeah.
Yeah, I was just going to say that I don't know that we, and Jen said this, we don't want to go down a rabbit hole with the way that the IDs are discovered, since that's not part of the draft anyway. I mean, it's required as a prerequisite, but which way? So I don't
Yeah.
think we need to mention every way in it, or know that we need to put BFD in this. I think the two existing ways that are there are enough myself. I'm speaking as a working group member.
Yeah, I think the draft clearly said the how to get the remote ID is out of scope of this document, but there are some recommendations how you can get the possible ways you can get it. So it's up to the authors.
Okay, we can discuss further.
Any other questions? Thank you.
Thank you.
The next one is mine. Can remote people hear me okay now? So I'm gonna do a quick update for the young drafts. Okay, so here are the list of young models we have published in the LSR working group. The last two in blue color are the ones we published since last IETF, since 124. And we have been trying to define young models together with the specification if the specification is not so large and the model is, we think is okay to be included in the draft. So if you look at this one, we did that for the administrative tag. So for these two drafts, the Anycast property advertisement and the unreachable link in OSPF, we have data models included in the draft as well. And for the link infinity one, there is an IANA model included in the document. And I will tell some details about how to define an IANA model and how it can be used later in the slides. And the OSPF flex algo Young model, both OSPF and ISS, these two have been submitted to the IESC I mentioned during the status, and they are in IETF last call. So here is an example of the IANA model. So when we defined the base OSPF model, we didn't know how to figure out IANA was maintaining all the modules. Now we have a way to, we have those code point in IANA registry. So we can actually define a corresponding module, IANA module for those registries. So for example, the one I have, this is the metric type. If you look at each identity, those are the registries defined in there. So the advantage of doing so is, later if a document extended the metric type, and since we already have the metric type configuration and the status available in some existing model, we actually don't need to define new model anymore. So the IANA will just add the new registry for it. So another example is, let's say we have the MSD type. If we already have ways to configure it and to query the status of it. So if later a draft define a new MSD type, we don't need to define any new model for it. This is just a way to show how it can be defined. So like the link infinity one, we actually define the functional capability base using a model. So later any draft that's using the functional capability base, we don't need to define new models anymore. But if you need any help of this, let me know. I'd be happy to help. So, and we still have the augmentations for additional features. And these are the list of features. We did move the flex algo to the separate module in order to get them published sooner. This we probably will pick important ones, get them published in line. Same for ISS. And we have the ISS picks module. We have 3 modules for ISS picks. We had quite some discussions when we adopted this draft, but since then it has been quiet. I suppose if there are no further comments, we will get this module ready to be published. So if you are, especially if you are a service provider, please take a look, see whether these modules will be useful for you, or if you have some comments, want to add something, let the authors know. And the ISS, OSPF, SRv6 Young, these two are pretty much waiting for the SRv6 base model in spring to be published. And these are the sequence we think we might be able to get published, how we plan to publish these models. Any questions? This is just a quick update. Otherwise, we'll go to the next presentation. Tony, is this
Yep,
the
I'm
right one?
here. Yep. Good night, good morning, 2 a.m. here. Nothing more exciting than talking about some scalability hacks for an arcane protocol. Yeah, do I get a clicker? Yeah, I get a clicker. Let's see what it works. Excellent. So this is basically the update on the desktop flat work going on. So what happened between the last draft, the 11 that we presented, I think we are 12 or 13. So first thing we cut over, and I won't, repeat any of what this thing is because I think I gave already 2 presses. I basically focused just on the changes and some interesting things that were happening in terms of implementation. So we cut over to Fletcher 16 for the fragments hash rather than what we had initially, which was some kind of a double hashing thing. I think the suggestion came from Tony Lee. So the stuff that delivers a better entropy and it's a standard algorithm, right? So it's much simpler for people to implement. Based on some implementation experience, we added clarification how to treat RFC 5120 as a multi-topology and the overload bit during computation. And there were some minor clauses to speed up convergence if CSNPs are not enabled and some corner cases, which is the usual stuff where you end up with some fragment being flooded and network partitioned and basically connected again, right? So there's some stale copies and part of the network. Everybody interested in the gory details, read the draft, please. Now, to the more interesting things. So we have a second full implementation done by Renato on Holo, which is actually a pretty large routing stack, fully rustified. You'll find the stuff on Git. So he implemented the thing without actually even talking to us upfront. So it seems like the draft is holding up because the implementation was basically correct. So when we were testing the stuff against the Juniper stack, we switched off the CSNPs because that's the best way to ensure that all these distributed algorithms are actually working correctly and look at performance without relying on the periodic CSNPs actually patching up stuff. And as often the case after we switched off the CSNPs, a couple of really nice flooding bugs have shown up in the Holo routing stack, so that has been fixed. And then we ran a full interoperability, again, without CSNPs. So a lot of link flapping, fragments refreshing, node reboots. And we built up mixed topologies up to about 100 nodes and ran it that way. And no performance testing has been done there because Holo does not have enough instrumentation for this kind of stuff, which could be done, but then, all the tooling that we have around, which was more like Juniper geared, would have to be also added for Holo and so on and so on. So we didn't go there. So basically, second full implementation, interoperability verified. Next one. And once we talk interoperability, so of course, it would have been nice to test it against the TLV in the flood reduction architecture. But we didn't because we don't have code points. So we neither have the code points. I'm just reading Chris's comments. Yes. So I recommend people to look at the Holo routing, the Rust stuff. It's actually quite a lot of things there. So thanks to Renato, of course. Right, so we didn't have the code points for the reduction architecture to actually compare whether nodes were running all the same algorithms and so on. So we'll need to request those code points at this point in time, both for the algorithm as well as the running algorithm, TLV or sub-TLV in the router capability. The other things was about this flood reduction architecture thing. So 2 authors joined, Jordan and AC. And they kind of, between them, worked out the whole OSPF signaling and support for it. I won't talk about that stuff, other people can update it because I wasn't heavily involved in the work. So yeah, so that's the status. Now, what we also did is we basically started to hammer on this distribution with what we can imagine is the worst case scenario. So basically massive link flapping on the topology. And the methodology was similar to what I was showing last time on a stable topology. Geometric graphs, because they looked very much in terms of graph theory properties like most of the large backbones that we're seeing. Yes, some big gear were measured with fast flooding and standard flooding, so 250 packets and 30 packets. And the way we were measuring basically flap on the topology, which I show, I'm just showing the largest topology that we ran the stuff on, was basically 10 random link flaps all over the place in the topology, and then let it stabilize and see how long did it take to synchronize the database everywhere, either with reduction or without reduction, CPU load, right? Because there's a lot of optimization caching going on the implementation. So you'll see there is a good amount of trashing going on, and what did happen to like retransmissions, transmissions, numbers, and so on. Logging switched off, right, to make the performance somehow realistic. Only one core per container to also make it kind of more realistic. CSNP switched off, right, as a precondition, like I said, best precondition to test the correctness and behavior without having, you know, belts and suspenders running. We ended up doing a couple of optimizations round, basically, you know, shaking the tree and finding where we were burning, especially the CPU during such a heavy stress. And everything done on Katara, always to be mentioned. Fantastic tooling when you go into this kind of work, you know, on containers. I can only recommend people looking at the stuff. Yes, good. So I give you quick spoilers in terms of result before we go and start to look at graphs. So it is the worst case for reduction that we were seeing, and of course massive cache trashing since the topology is fluctuating all the time. What we were seeing after a round of optimizations are still going on, but we're kind of pretty happy at this point in time that under such massive flapping, what we're seeing is about 20% higher CPU consumption across the network based on all this cache trashing going on. What we see is that it's beneficial for the implementation to have something like you know, a threshold, a hold down threshold, just like SPF computation. To have you know, limitations on number of computations that you run to decide what is the flooding reduction graph or whatever we call it, that will basically squelch the computations if there's too much going on, and the node can simply fall back to full flooding if the CPU load is too high. So we have those thresholds. Even here under this heavy load, we can, you know, kick them in testing, but even under such a heavy load here, I couldn't actually trigger those thresholds. But that's, you know, kind of a result, interesting result that fell out of the work. Then what we see on the convergence after transmission metric, I show a couple of graphs, we still see that the stuff is beneficial, but of course much less so than on a stable topology. All right, so my usual graphs, right, on the vertical axis is the number of nodes. It's always the distribution. Or horizontal axis is whatever we're measuring, like CPUs or synchronization delays, whatever it is. And blue is always with reduction, orange is without reduction. So let's go and look at a few graphs. And so that's the graph that we ran, about 100 nodes, 15 sources, about 7K prefixes, around 1,000 links plus, something like this. And like I said, shaking 10 random links and then seeing what happens. So as you see on the CPU consumption, right, the reduction, both in fast flooding, normal flooding, is actually kicking around 20% more CPU across the network. Nothing dramatic, but kind of, you know, validates there's extra work to be done computation-wise. When you look at the reduction, that's the reduction percentage divided by 10. You see there is very little reduction going on, which, of course, due to all this extensive trashing, the stuff cannot stabilize caches and start to reduce heavily. So we're only seeing like, 10, 20, maybe 30% reduction if you note. The faster the flooding, the less we see, probably because just flooding outruns, the computational reduction. Convergence. So even in such a bad scenarios, you see that the reduction benefits, the database converge faster. Nothing super massive, but it still shows, in normal flooding has more benefit. With fast flooding, of course, even, without reduction, stuff catches up quicker. So that was a very good result, but it took a couple of optimization rounds to get here, to be honest. LSP duplicates that you see, so basically how many LSPs at the end were flooded that were not necessary compared to, optimal flooding. You see that the stuff is kind of comparable. The difference is not much. When we look at the LSP's number of transmissions, if you look later, this graph is a kind of interesting result, right? The faster you transmit, you tend to transmit less, somewhere a little bit less, but the reduction starts to transmit more. I will not drill that stuff farther, but you see the effect is not particularly dramatic. All right. And so conclusions, second, full implementation, interoperability verified. Even under the worst topology stressing scenario, we see that it is somewhat beneficial, although you pay a little bit of CPU. And yeah, we need code points now for full interoperability, and the stuff going into deployment. Thanks, that's it.
Thanks, Tony. AC, are you in line for questions?
Yes, I am. I think this is, maybe I missed it the last time, but I think this is interesting. With this level of intelligence in the flooding, you actually use more CPU than the I/O you save by reducing the flooding. But in doing so, you converge faster. Yeah. Which is the main benefit. I mean, if I were going to summarize it in 2 sentences, that's what I would say.
Well, I mean, this is this discussion, do you have the CPU to burn, right? I mean, it's a multi-protocol box, so if BGP is already 99.99 all your cores, then the 20% CPU may be something that you don't want to pay for somewhat, a better convergence. Although the somewhat better convergence is very, very relative, right? If you have a stable topology and you have people reissuing the fragments, that the gains are dramatic. So you may be way better off, because you even won't be burning the CPU, right? If the caches are stable, then it costs you nothing on a stable topology. This is the worst case. This is basically topology going haywire, at which point in time all your caches go to hell. So if you assume a stable topology, it's always a big gain because you don't pay CPU tax, but you get a lot of gain, right, on the reduction, because the cache lookups are basically for free when you look CPU-wise. If you have a topology which is highly unstable, but then probably you have a lot of other problems with BGP and everything else anyway. So this little CPU overhead is probably not particularly, relevant in the whole realm of the whole discussion. I thought it was just, to show the whole envelope, right, of the whole thing, which we need to do internally on our implementation anyway. I thought I show what we see as the worst case for this kind of technology, to show the full envelope. Yeah.
It would be good to show also for the same failure, for the same disruption in the network, same changes, how much I/O you save. Well, I think you did have one thing with the LSPs, but
that's the transmission, right? And that's the LSP duplicates, which are kind of the 2 metrics. You can look at the retransmissions, but doing such a heavy flooding, it's kind of very difficult because you get weird effects, like one side of the adjacency already thinks three-way and starts to flat, while the other side is not full three-way yet, so it starts to drop those LSP, and it looks like actually you have LSP drops, which are not real. You know what I mean? So the duplicates in the transmission are kind of the best metrics you can pull and interpret. And as you see, the difference is in single-digit %. So it's not particularly relevant. This is over 3 or 4 runs, so I don't have confidence intervals here. But the stuff is running fairly consistent. So in such a trashing case, you don't pay a big IO tax. Whereas I was showing last time kind of the best the best case scenario. There you of course see that you have massive IO gains. Okay.
Okay.
Yeah, so the things that people design for, like single or even a couple, single link failure, single node failure, those types of things, you'd see a real reduction in the IO.
Because most of the networks will have caches stable, right? This is also kind of a very bad network because that's why I've shown the graph. The average distance is relatively small. So normally people will have some, this is representing roughly the large networks, what we're seeing in terms of, average properties of the graph. If you have a single link fail, the radius impact is 2 hops, right? So everything within 2 hops will kind of, the caches will flap somewhat. Whereas the rest of the network, all the caches.
AC, can you hear me?
I can hear you now. It seems when I mute my audio, the sound goes up.
I can hear you now too.
We lost Tony.
Yeah, we don't see the screen either. But as Tony was just coming out.
How about we go to the next presentation?
I think that, yeah, we could do that. I think
Yeah,
we're
because
experiencing
next
that.
one will be Tony Lee. He's here.
Okay. Yeah, just know that the remote, I think we're experiencing some pretty bad network failures.
Ni hao. I'm Tony Lee. I'm here to present power conserving path placement strategy. And I'm told I have to eat the mic, okay? Last time in Montreal, Colby came up and presented all of our proposals for how to add power consumption information to ISIS. And he got the question of how do you use it? This presentation is out to answer that question. So the problem we're trying to solve here is pretty simple. We have to provision networks to peak utilization. However, lots and lots of networks, especially eyeball networks, have daily utilization patterns where traffic falls off at night because humans are driving it. If you stop streaming, guess what? So then we have excess capacity after everyone goes to sleep, yet we're running the network at full power. This can actually be significant. Some public numbers, BT, the ISP for the British Isles, consumes 1% of the power in the British Isles. And at the same time, in their low traffic levels, they're 85% idle. So 85% of that 1% is being wasted. We would like to not do that. Okay, so how about we turn things off when we're not using them? All right. What we would like to do is when we have low traffic, we would like to push traffic onto a small set of links, right? You use 15% of our links, maybe a few more for redundancy purposes, but turn off lots and lots of other links. Okay. If we can move the traffic and leave things idle, then powering things down, and especially powering off the silicon, saves lots of power. Now, doing this is not too difficult. We've described how to understand the power used by each node in the network and each interface. And now we're going to modify CSPF. CSPF is constrained shortest path first. This is the algorithm we do for most traffic engineering. And yes, we're going to be presenting this in T's as well. So it's relatively easy to take CSPF and modify it to take into account power utilization. Before we add power to it, CSPF looks at each TE metric on a link and then computes a path from source to destination that follows the constraints that the network manager requests, and then finds the path with the lowest cumulative TE metric. Once you start considering power, things aren't too different. Okay, again, we're going to respect all of the constraints, but now we're going to look at the power metric as well. What we're doing is to have each ingress node compute the power metric. It's influenced by the power information. Okay. The exact computation of this metric is out of scope, i.e., we're not talking about it. Okay. Does not need to be identical in every node. Every head end can do its own thing. And this is a place where we can do some various degrees of innovation. The power information is all there in the IGP. You have the power on an interface. Each interface belongs to one or more power groups. The power groups represent an abstraction of higher level hardware that you can take a look at to understand the total power consumption demanded by each interface. All of this is flooded in the IGP, can be then copied into the traffic engineering database, TED, and that's all described in this draft. We also imply from that that certain things can be powered down. Obviously, for redundancy purposes and for latency purposes, there are things that you may not want to power down. That's okay. We give you that level of control. As I mentioned, the power groups describe the power consumed by components, hardware components in the box. And the draft gets into details about how to do this. In the case where an adjacency is on a lag, a adjacency may have multiple power group parents. And also to handle the case where we are dealing with lags and we've turned off members of a lag, we also track the unidirectional sleeping bandwidth. This way, if a lag has been turned down by 50%, you can tell that and react accordingly. Sleeping links are an interesting challenge. As you know, ISIS only distributes active adjacencies, and we actually want to distribute information about links that are asleep. We want to keep those in TED for further computation. So what we did was to go ahead and take those adjacency TLVs, Most of them make use of something called auto bandwidth, which actually does make before break and changes paths almost constantly. Typically, people are changing paths about every 15 minutes. So this has just becomes part of that optimization.
Okay, thank you. Just answer NVIDIA. Tony, are you going to provide BGPLS extensions?
Not at this point yet. One thing at a time.
Thank you.
All right. So we're ready to move this forward. We would like to adapt this as a working group document and have draft mini LSR power group also as a working group document.
AC, you are the next one.
Yeah, this is just speaking as a working group member first. I think you should, this presumes the majority of the traffic is engineered, which is okay, but I think you should say something about that, about the best effort and how that is, if it just follows whatever available paths are there. And in these types of networks where everything's engineered, you can use the proper words there. But
we'd be happy to note that. Most of our customers do use traffic engineering to engineer almost all of their traffic. Dark traffic that is not being engineered obviously is not affected by this, and of course may cause you to not power things off.
right. The other thing I was going to say as working group chair is, I think the many document that does belong in T's, where the power group but belongs in LSR.
We would be happy to do that too. Any other questions?
Les, you are the next one.
Yeah, so Tony, this question is not just for you, it's also to the working group and perhaps the working group chairs. I think there are many ideas out there about how to incorporate power efficiencies in routing. I'd like to get a feel for whether this solution is a solution that customers are eager to deploy, to the extent that you can talk about that.
I can say that our customers want us to implement this. Our customers want you to implement it too.
Okay, thanks.
Zafar.
Yeah, so I think to second what Les mentioned, I wouldn't say that our customer want us to implement this. There is quite a bit of unknowns here, especially the way that you define the power group. You presented the LSR draft last time, and there was a discussion regarding the metric needs to happen with some condition with the green working group. And I believe there was some action taken. I don't know what was the outcome of those actions. And then your presentation was for a TEAS working group, and you are asking for adoption in LSR. So that was a bit confusing, but I think some work needs to happen in terms of the requirements for this, what customer wants, the metric, before the working group will proceed.
The customer wants to save power because power is money. Green working group seems to be intent on modeling the world and ignoring how to actually save any kind of money. So we're ignoring green working group.
I mean, yeah, if you have some problem with green working group, they're not doing the real work, then you need to talk with the green working group. But there is certain things, there's some precedence in IETF that needs to happen, especially when it comes to metrics. You look at the charter for green working group.
I helped write the charter for the green working group. I helped start the green working group, and I contributed the first draft to the green working group, and they've subsequently ignored it. Okay, so that's fair. They want to ignore it. They got a better idea on how to do things. They're welcome to do that. They don't seem to be actually solving customer problems. We're going to let them do that.
Okay, I'll let Chair NAD chime in, but it's fine. Thank you. Appreciate that.
Jaffa, okay. Jay, you are next.
Yeah, Jadon from Huawei. I'd like to ask a question about the metric. It seems you're talking about the metric can be used customized algorithm to get the metric by different nodes. Is that something you're
Yes,
in the
that's
draft?
what it said. You can do what you like with power information to compute the metric.
In that case, how can you get a consistent view about the metric if the different nodes use different algorithms to get this metric?
Okay. Take a look at bullet 2, sub-bullet 1. The metric does not need to be identical on every node. It does not matter. This is path computation that we're doing here.
Yeah, but
every head end is allowed to compute whatever path it wants. It does not need to be consistent with every other node.
Yeah, that sounds like you are using different metric types for computation of a path on different nodes.
I didn't say that.
Okay, that's maybe
I
something.
think the point is that when you have a centralized path computation, that you don't require that everyone agrees on what the metric means, right? When you have a distributed computation.
I know that is a
becomes
centralized
more important.
computation. Just the information collected maybe based on different criteria to get the metric. So maybe the total metric for a path may not be the most energy efficient from the perspective of the controller of the operator.
Well, I think this is a great comment for the list too. This would get some discussion going.
Yeah, it's not required that everyone agree on what the most optimal power metric is. Okay, and what you consider to be power efficient is not necessarily what I consider to be power efficient. Okay? I have this weird warped perspective that I want to turn off as much power as possible. So I care about turning off ASICs. That's what I optimize for.
Yeah, another quick question is, will this metric be very dynamic, or it's like a kind of static?
So again, with ISIS, if you have a dynamic metric, you tend to thrash the LSTB, you thrash flooding, and generally that's a really bad idea.
So it's static, right?
I didn't say it had to be static.
It's relatively stable?
Yeah, yes, of course. You want something that's relatively stable.
Yeah, so the algorithm may be something important.
If you introduce a 1 gigahertz input signal into ISIS, I guarantee you'll have a bad day.
Okay, thank you.
Yeah. Rakesh, you are the.
Rakesh Gandhi from Cisco Systems. Slide 4, I think you are talking about optimizing this new metric instead of T metric. There is also a requirement for low latency traffic, and there is path computation with latency metric to minimize the end-to-end latency, for example. So if you're just focusing on PC, PPS metric optimization and not looking at low latency requirement, you may get in trouble with some SLAs, right?
So you'll see the words there, does not violate constraints. Okay, we did not talk about every possible constraint. We've been talking about constraints in traffic engineering for about 30 years now. We think most people understand it.
So it's keeping the existing constraints, but adding additional end-to-end cumulative metric minimization. That's what you say.
Absolutely.
Okay, thanks.
Okay, Jafar, you are the next one.
Yeah, and that come back to the same thing, is that without consistency, you are not doing the right traffic engineering, because some node may give a metric which is way off from the other node, but the actual power saving is something that is very different from each other. So this is where the normalization, some kind of normalization is needed, some consistency is needed. We can talk offline more, like in Keith's working group, but
Yes, but doesn't the operator just stop buying that box then? Isn't that just a bug?
Chris, you're very choppy for me. Sorry, I apologize.
If you are lying to your customers, you get what you deserve. Feel free.
Anyway, Tony, we can take it offline, but it has to be some consistency, some normalization, some proper
Yeah, yeah.
definition for. Okay.
Hey, I think what the draft says is that it's, speaking as working group chair, and we'll move on, and we can take it off this. I think what the draft says is it's out of scope. Should the measurement of milliwatts be consistent? Yes, but that's really out of scope for this draft.
In scope, what work?
To be
Anyway.
fair, the normalized unit for power consumption is the watt, okay? If you don't understand it, I refer you to your local physics professor.
Okay.
Okay. Anyway, we can take it offline.
Okay. Ron, please.
I think there are a few things we can agree on. One is the customers do want to save power. Two is that there's definitely a CSPF part of this. You need to steer the traffic so you can shut down nodes. And if there's a CSPF part, CSPF has to learn stuff from remote nodes, which means there's an ISIS part. That suggests to me that there's enough motivation here for a call for adoption. The answers that we propose may not be the final answers, but this is certainly something that I think the working group should be working on. And then ask for a call for adoption.
Okay, thanks. Jeff, you're the next one.
Jeff Mantura, Media. You mentioned ASIC a couple of times. What's the correlation between adjacency and ASIC?
So this is exactly why we have power groups, because there are multiple adjacencies that may be dependent on a single ASIC. And so a power group can be used to model an ASIC, or can be used to model a set of ASICs, or even an entire line card. So there are lots of things you can do. We're not picky about how you model it. That's why we left it as vague as possible. So you can do things hierarchically, that's all we asked. But for lags, you can have multiple parents because you could be using, say, even multiple line cards in the same chassis. So you have a great deal of option about how you want to model particular situations.
So it's an abstraction. In other words, would you support hierarchy of abstractions in case of lags?
You can deal with any abstraction that your box cares to name. If there's some mechanism that we haven't foreseen, then please let us know.
No, you expect PC to understand the relativity of levels, right?
So there's no bound on the number of levels. You're welcome to do whatever you like.
Thank you.
All we ask is that you not introduce cycles in the power groups. That would be bad.
Martin, yeah, please.
Yeah, I do like the concept of your abstract power groups perfectly. I just wonder whether the whole topology and maybe hierarchical level of power groups makes it a trivial optimization algorithm or method that can be handled distributedly at all.
We don't claim that this is absolutely optimal, but it is an optimization, which is to say we don't claim that we got this perfect.
Okay, I think we finally finished the line.
Thank you very much.
Any other questions? If not, okay, please continue the discussion in the mailing list. Derek, you're on the next one.
Hello. Hey, hello everyone. I'm Derek Young from ARCIS. I'm here talking about the advertising IGP measurement groups on behalf of my other co-workers, co-authors, and from ARCIS and Equinix. So the problem statement motivation is that in the customer networks, they want to run measurements using trams or STAM, and they want to, currently they need to go and do all the configuration themselves to figure out this, what router need to be connected to do the measurement, and it's very time consuming. Yeah, and very troublesome. And so the requirement is that could we have IGP router auto discovery, which router want to do the measurement, and this measurement need to be potentially leakable across areas if needed, and we need to advertise the address of the interface to identify which interface or which the membership of the interface that want to be measuring a particular mechanism like tram or STEM. And of course, the same address could be used for used for multiple measurement group if they are such configure. So here is the proposed TLV, and it's very simple. It has basically include IP address and then indicated which protocol is going to use that address. And currently we define two of them, tram and STEM. So how it operate? So the router that want to participate into this measurement group advertise the TLV, the sub TLV, specify the address they want to use, and they can advertise multiple instances of the same sub TLV if they want to have like different addresses for different protocol. And then the receiver, you'll get a group of information of the membership, and they'll build a database, and then they can use the database to communicate with other component on their routers, and those components use the information to make connection and do the measurement. As usual, the router capability TLV could be propagated across area boundaries needed, configured to do so, so that it meet the requirement that it could be a domain-wide distribution. So basically, after all this is done, if anything change, memory change, new box come up or box go away, it gets detected, and the receiver will update their database accordingly and cause the component, the measurement component, to react accordingly. So summary and next step. So of course, we want to do this. We need to get the subhero type, and we need to assign the bit if we keep the encoding as is. Nothing much change about security. It's the same thing that in ISI as before, using authentication with your friends. Now, what we want to figure out this time is that to identify whether there's the other people, other operators that have the same need, and also whether this approach of carrying this data in IGP is a valid approach. Working groups. In orders, then we'll have an update, and they'll include other protocol like OSPF in the future. Okay, thank you guys. Any question, comment?
Martin, are you in queue for questions, or is it from last time? Okay. Any questions, comments? Oh, maybe we can do the discussion in the AC.
Just speaking as a working group member and a co-author, this is we were talking about this and how this fit with the IGPs, and it's somewhat similar to the seamless BFD advertisement and the capabilities. It's a very small amount of information, and the resulting computations could be used for traffic engineering. So I think it does fit in ISIS and OSPF.
Okay, finish?
Yep.
Okay. Well, thank you, Derek.
Okay. By the way, it's not moving.
the script stopped moving a while back. So, Tony, you are the next one.
Yeah, here I am. Let's hope I don't get squelched up again.
Yeah, and you have control of the slides. Please go ahead.
Thanks so much. All right, so that's an update on the hierarchical S&Ps, HS&Ps. What we're seeing, interesting things. Let's fire it. All right, so what happened between the last time and now? Pretty massive readability rewrite based on some feedback. Perplexity AI to be blamed for anything that looks funny. The big change is that the original draft was suggesting that the HS&Ps have some kind of ranks. Yeah, levels, bad word, because we always get confused with ISI's levels. That has been abandoned completely. I talk about why. You know me, I like to heat up CPUs a lot. So I did quite a lot of work on actually building an emulation of very large networks, doing refreshes over very long periods of time, so generating HS&Ps and all those hashes to look at collision probabilities, right? To get some kind of a hang on those things. And one practical thing fell out of this work for the fragment Fletcher, right? Because the HS&P hash for the fragment is a Fletcher. We changed that. Is that we added the ISI's MTU length or PDU length that is in the packet, which is actually a good source of entropy as well to get those hashes more evenly distributed. All right. So why did we abandon this level of rank? Because with the implementation, we're seeing that there isn't anything like that, because different parts of the LSDB compress at different density. And that depends on a lot of things, right? So the strategy implementation may choose is not something that we can standardize. And it's not only varies over time, but also per peer, right? Because talking to different peers, these peers may have LSDBs in different states. So the agreeing on consistency and what needs to be exchanged can not only vary on time, but also per peer. All right. And the strategy node can choose to actually decide how much it compresses. So, you know, how many nodes it covers with the hash. Can be based on a lot of different variables that we're seeing. So you can keep some statistics, right, about how many of mismatches did you see to appear. And if you see a lot of mismatches, you can come to a conclusion it's not worth to compress anything of this part of the database. A link flap is very different from a node reboot, right? Because if the neighbor reboots, it basically loses the whole database. So there is nothing to talk reasonably about at high level. Whereas during and Lorenzo says something. Okay, no, irrelevant. Whereas if a link flap, the databases are basically synchronized on both sides. So HS&Ps, you know, large hashes or hashes covering large part of the database can help a lot. People can have in implementation different caching strategies for all those hashes or whatever not. So that also can influence how dense they want to make those HS&Ps, or you know how large these hashes are in terms of covering parts of the database. And then there's other consideration like, you know, hashing of CS&Ps, and for example, generating CS&Ps may be extremely cheap compared to HS&Ps. So you don't want to have hashes where you may want to have hashes that actually trigger a lot of CS&Ps if they mismatch because they're very easy for you, or maybe not. And I think last time the topic came up, but again, to emphasize it again, to like agreeing on all the peers on what are the ranges that the hashes cover seems like an easy and natural idea, but it's actually not feasible for reasons that actually I discussed last time on the mic with Chris. Good. So a good analogy, you know, why these HSPs are useful is you can consider them basically a gradient descent. If you're familiar with, you know, like the most basic stuff in AI, So these HSNPs you can consider, the optimum is both databases being synchronized, and these HSNPs can be considered the large steps on a gradient descent, right? And if the hash is matched, it means you descend very quickly towards a database that is consistent on both sides. And if you mismatch, you basically have to take smaller steps. Why this analogy is helpful? Because it basically leads directly to advertisement rules, which are described loosely right now in the draft, and Les pointed out correctly that this has, of course, to be formalized very strictly in a normative language. But we're waiting for the whole discussion and the draft to settle and the ideas and first implementations before going into all this tedious necessary work. But this gradient descent analogy, if you think through it, leads to basically fairly simple rules, right? Basically, when you get an HSNP hash over a range of nodes that mismatches, then you have to take smaller steps. And the smaller steps is either to send an HSNP packets with more specific hashes for the mismatch, right? So kind of disaggregate the range into better, smaller hashes. Or you can react by basically sending CSNPs for the mismatch directly, which are really small steps, which the protocol is taking today, if you think about it. Or that the very smallest step where you can be pretty much sure that the databases are consistent on the ranges, you basically flood all the involved fragments, right? So, of course, it's very implementation dependent. There's a lot of considerations about, optimal strategy and so on. But in architectural terms, this is basically going from a big step on a gradient descent to smaller steps, which will be more precise, get you in the right direction. And at the point in time where an HSNP hash is covering just a single node and node ID, which means all the pseudonodes and all the fragments of the node and the pseudonodes, then the action will become just the last two steps, right? Because you cannot send a more specific HSNP hash. The smallest resolution of HSNP hash is basically, a node ID. So then you either send PSNPs, or otherwise you flood directly. So that's, I think, helpful if you think why the whole thing works and what will be ultimately, the precise language of the standardization for the whole thing to work correctly. All right, now minor changes. So there is the funky case where a flat share of a fragment can become 0, which is actually a valid, funny enough, valid case. And the draft says replace it with 1. So during XORing into a HSNP range, the stuff is visible. And we look at the case where a different set of fragments with different flat shares will create the same node hash. And when you look at the probability of that stuff, it's so incredibly unlikely. It's not worth considering further. You find something in the draft. And there was a stupid idea initiated by me, as very often, that if we have an HSNP packet and the range is in the range of the HSNP packet, we have multiple hashes, right? And they may be whole in these ranges of each HSNP hashes. We could advertise the missing range with the hash 0 indicating absence, but that's actually dumb, because what could happen is that multiple node hashes XOR each other out, and the 0 as a HSNP hash for the node range is actually 0. It's a valid case, so that needs to be removed. I'm getting into a little bit arcane details here. Now, anyway, the meat of the stuff is that I burned a lot of CPU powers to look at the hash collisions. And basically, what I built is a perfect emulation of a network where everybody's refreshing. I was running 32 networks, just amount of cores that I had. Each network 50K nodes and total about 1 million fragments. And each network was running for 2 years, refreshing, right? Refreshing and a little bit more than that. I use roughly max age to refresh fragments. Some are lower, like 50K seconds or something like that. I did not make the node IDs too different. So the node IDs, which are used in the hashing, were only differing by 3 bytes, which is kind of realistic or pretty, no. You can argue already a fairly suboptimal case if you have a 50K nodes network and you basically, if node IDs, you only squeeze it into 3 bytes difference. Only on 5% of refreshes, I was changing the ISI's PDU length. So assuming that the network is basically refreshing all the time the same thing. The checksums, I assumed, would be moving in fairly uniform fashion, and the checksums will be changing because the sequence numbers are bumping, right? And the sequence number is in the ISI's checksum. And while the stuff was running, I was basically every time something refreshed, I was checking the whole database, whether there's a collision of an HSNP fragment. So pretty much mirroring, you know, the reality of that stuff as far as it mattered. Now, what did we see? So 32 bits HSNP hash is too small, that will collide too much. So we were running 48 and 64 bits. Astute observer will realize that there is no 48 bits Fletcher, but it's very easy to extend Fletcher to do actually 48. And I will show you a graph, right? And this is the quintessential graph that shows that actually 48 bits work better than 64 bits, which is kind of surprising. And I have some gut feeling why that is, but no real data to back up, you know, what would cause the effect or you know, a theory, foundational theory. But I see it on the graph, so you see the graph. So horizontally, you will see there is the distance between the fragments that collided in LSDB, right, and how many collisions. And vertically, you'll see how long does the collision stay in the network, because that also matters. And the red line on the graph will show you what is basically a coverage of the whole database by a single HSNP packet with about 60 or 70 hashes. And the green line is what if you decide to generate up to 80 HSNP packets, which is like, you know, 80 times 70 hashes. We're talking a million fragments database, right? So serious stuff. And then numbers close to the line show how many collisions happen that matter. And I show you what it means that matter. And once we go to 64-bit hashes, then in fact shows up that, of course, less hashes fit into an HSNP packet. So that starts also to play a role. Because a single packet covers, you know, if you want to cover the same range in a single HSNP packet with 64 bits, you will have less hashes that you can generate. So each hash to cover a larger part of the database. And I also will say in the draft that you can, for the collision, find a perfect remediation technique, right? You can go observe the whole database, walk the database, just look within the range where it matters, and so on and so on. I don't think it is practical if you start to look at the amount of I/O involved and CPU involved. CPU even kind of less than the I/O. Right, so to the graph, which is the last thing, and that's the interesting graph. So like I said, on the left is 64 bits, on the right is 48 bits. And I go through the stuff again. It's all logarithmic because we talk really large stuff, right? So in the horizontal scale, right, so the blue things are collisions. On the horizontal axis, you see the distance of the collision. So how far were the things in database when they collided? And that matters. And on the vertical axis, you see the duration. So the duration was, you know, somewhere a little bit less than the lifetime of a fragment. So we're talking about 10 hours, something like that. Now, the red line means that only a single HSNP packet summarized the whole database, right? And you see that now, why is it important what is left of the right of the line? Because right of the line means that the collision distance was so far apart that it didn't matter. It was not in the same HSNP hash. So for practical purposes, those collisions did not matter. Left of the line, it means that it was in the same HSNP hash possibly. And that means that if you sort both, that they both vanished. All right, I hope people can follow that. If you're familiar with the details of the draft, it makes sense. But what it shows is here that the 48 bits lots of these collisions didn't matter. Albeit it generated, you see at the top, at the very right, 230 collisions, whereas the 64 bits only generated 190 collisions. We're talking here something to the order of 36 billion refreshes, right? 32 networks running over 2 years, each of them 1 million fragments. So to even get those 200 collisions, you need to run about 36 billion refreshes. But let's go back to those lines, right? So on the 48 bits, what we're seeing, if you generate a single HSNP packet for the whole database, which is the red line, you get 109 collisions. There was a pointer, I think, somewhere, but I hope you can follow me. So that's the 109 number. So if you translate these 109 collisions over the whole thing, it basically means that we will be seeing about 1 collision for about 10 hours every year, okay? So that's what we're talking. If we generate, however, like 70 or 80 HSNP packets to cover the whole database, we're seeing 1 collision for 10 hours in about 10 years. So, you know, practically, this is all pretty much irrelevant, because if you start to look like what will happen if you have to generate that many CSNPs, the flooding rates are become completely unsustainable. So we can't actually use CSNPs, practically speaking, to synchronize these kind of databases. So, you know, unless the flooding is perfect, super perfect, we don't have a solution until we go to something like these HSNPs. And on the 64 bits, you see that albeit we have less collisions, they cluster much closer, which means that they will be more relevant. We'll see actually more relevant collisions than with the 48 bits hash. One thing remains to be seen is probably to go and look something like zip hash. I had some discussion with Job Snyders. You know, we may go and look at the stuff. The problem with that is, of course, that everybody knows Fletcher. When we start to go into go zip, we have different variants. People have to implement it, and so on and so on. But you see that the numbers with 48 bits look like it's practically absolutely viable to run those HSNPs. The collisions will not show up in any relevant form and fashion to matter. You know, what was my conclusion? And yeah, I think that's all I have for the moment as far as these works go. Thanks.
Okay, thanks, Tony. Questions, comments? I don't see anybody in queue.
Yeah, and thanks to Les, right? He's keeping me honest, and he has a lot of good comments, like throwing at the draft. Yeah. Mm-hmm.
Hopefully I switched mics. Hopefully this isn't horrible. You said you have a feel for the collision? Can you say what you think it is quick?
Sorry, I couldn't parse your question. What do you mean quick? I don't get you.
You said you had a feel for why 64 bits was not as good as 48.
Yeah, because it looks like when you go for the 48 bits and you run the hash over this sequence of things, that the node IDs somehow have enough influence, or they naturally partition the hash. You know what I mean? So the node ID kind of puts it into the different bucket. Whereas with 64 bits, the effect vanishes. The hashes become so uniformly distributed that they start to collide more. But it's just a gut feeling, you know. It's really hard to look at those things and have any conclusions, especially since, you know, this 36 billion things run for, you know, is heating up, you know, water-cooled machine for a day or two just to get this kind of graph. Mm-hmm.
Thanks.
Okay.
But you know, after I run zip hash, I may show up with something completely different, right? So this is just Fletcher right now.
Okay. I don't see people in the queue, so thank you, Tony.
Excellent. Thanks.
So this will be our last presentation.
Yeah, so good morning, everyone. This is Li Zhang from Huawei. I will introduce the IGP extensions for server interface relationship information on behalf of my colleagues. So the motivation is that alternate T-paths can be used for traffic load balancing when the shortest path is becoming congested. So, but this requires the devices to know the bandwidth information of other links. So, but there are already some documents that it turns the ECS and the OSPF to advertise the link bandwidth information and also the utilized bandwidth information. However, there are also some scenarios that the ECS or OSPF they establish neighbors through the sub interfaces. So when the two directly connected ECS neighbors are established through the sub interface, the link bandwidth and also the utilized bandwidth information just inherited from their parent physical interfaces. Then the remote devices will now know that the relationship between the sub interfaces and their parent physical interfaces. Therefore, the remote devices don't know the link bandwidth and utilized bandwidth is shared among the sub interfaces. So this makes the remote link based on the sub interfaces difficult to participate in the traffic load balancing as an alternate path. So our document extends the IGP to allowing a network device to advertise the relationship between a physical interface and its sub-interfaces. So let's take the SS as an example. We define a new type of TLV, sub-TLV, which is named the physical local link information sub-TLV. It can be used in the 22 and 222 TLV. It carries the physical local link identifier and also have some sub-TLVs failed to carry the bandwidth utilized information and also the physical bandwidth information of the physical interface. So this page shows a detailed use case where this information can be applied, considering a network topology with 4 nodes, node A, B, C, and D, and for traffic from node A to node C, and there are 2 links between node C and D, and these 2 links are established from two sub interfaces, and but they are from the same physical interfaces, and both the link from A to B and the physical link from D to C are only 30 Gbps per second are available. So if the traffic rate is 6 Gbps per second, then we can calculate a primary path which is from AB to C and alternate path from AD to C. So if the devices A don't know the doesn't know the sub-interface information from D to C, then it will say, oh, there are 3 paths and I can allocate 20 Gbps per second on each path. And so then the interface from D to C will congested because it is overloaded. It is carried about 40 Gbps per second traffic. And if the device A can know the sub-interface relationship information, it will say, okay, there is only 2 paths, and then it can allocate 30 G per second, bit per second on each path, and all the paths work as well. Okay, so I think is this motivation clear for this draft? And we also welcome for collaborators to work together on this work, and also welcome for suggestions and comments to improve this document.
Hi, Tony Lee, HPE. I asked this question on the mailing list. I didn't get a really satisfactory answer, so I'm going to ask again. It seems like the only topology where this happens is where you've got parallel VLANs on the same Ethernet. And I have to ask, why would you architect the network this way? Because it seems like a strange, strange thing to do.
Well, I see this question, but yes, there are actually some practical network employment that uses several VLANs or physical link. That maybe we can provide this use case next version.
I understand using multiple VLANs. Okay, usually this is for traffic separation because it's different administrations. But normally they don't use the same ISIS instance over multiple VLANs.
Yeah, okay, thank you. I will consider your comments.
Les, you are the next one.
Yeah, could you go back one slide, I believe? So, yeah, thank you. So what's happening here is, and by the way, I agree with what Tony has said. I think it's a strange use case, but even if it happens, you are advertising two IS neighbor TLVs between D and C.
Yes.
And as you have pointed out, even in the draft, from the point of view of a node like A, who's remote, A doesn't know anything about the relationship between D and C and doesn't need to. And in those two neighbor advertisements, assuming that D has some way of partitioning the bandwidth between the VLANs, which you're going to need anyways, no matter how you advertise it, you can advertise it in the two different neighbor TLVs, one for VLAN 1 and one for VLAN 2. I just don't see why you have to invent a new way of advertising information when you already have the ability to do that.
Yes, I think we can discuss this is in the mailing list. Yeah, I got answer
Okay.
this question now. Yeah.
So one other quick thing, if you go back, I think to your first slide.
Yes. Here.
No, I think it's slide 3. I think.
This one.
Yeah, yeah. So bullet point 2 is false. You've made that assumption. This is not true. You don't.
1, 2 is not right.
Yeah, there's nothing that insists that you have to advertise the same bandwidth on the two sub interfaces.
Yes, I think our implement is in this way.
Okay, thank you.
Thank you.
Okay, Lizzie, you are the next one. AC, you are the next
speaking.
one.
Yeah, speaking as AC Linda Erica speaking as working group member. Yeah, I noticed that your slides, you only had the physical group identifier, which I understand what you're doing there. I agree that this is strange to need to do this because you will have separate for the separate interfaces. But in the draft, there was also these other TLBs. I was going to bring it up, bring up the draft as well that you didn't talk about in your presentation. The ones the first TLB you talk about that goes in the neighbor advertisement.
Yeah. So what's the question? I didn't get it.
You provide it seems It seems you could do everything with the TLV that you have in your presentation in 2.2.
Yes.
What is the TLV that's added to the neighbor in 2.1 in the draft?
2.1.
Section 2.1 of the draft.
Yeah, well, if you don't remember, I guess take to the list.
Yeah. Please take it to the list. I can't remember
Okay.
it. Okay, thank you.
Yeah, you're the next. Okay.
Yeah. This is Lian from China Mobile, and just want to confirm that could you please go to the slides of the use case?
Here, yes.
That the purpose of the draft is to know the relationship between the D and D1 and D2.
Yeah.
Oh, I understand. And I have just a quick read the draft. I found that maybe the new TLV, you should consider the length because sometimes there are so many sub-interface under one physical interface, so the length may be very big. So maybe you should consider this situation on your draft. And also, I found that the OSPF extension is not specified.
Yes.
Maybe you can add later.
Yes, it's just the 0.0 version. Yeah, we'll do it later.
Okay, thank you.
Thank you.
Any other questions, comments? Okay. You do have some questions you need to answer in the mailing list. Thank you.
Yeah, okay, thank you.
With that, I think we finished all the items on the agenda. So any questions to the working group or anything about OSPF or ASS? Yeah, please go ahead, Kirati.
Hey, so I have a draft on capabilities to signal to the network whether a node is capable of doing MPTE or not. It's not a high priority right now, but if the multipath TE stuff starts taking off, it'll be important so that you can signal through nodes that can actually support this. So at some point, I will bring it to this work group.
Okay.
I looked at that, Kariti. That was a very drafty draft. It needs some more encodings and some more specification.
So I suppose we'll hear your presentation in Vienna.
Sure, yeah.
Okay.
And maybe AC, you can send me comments about how to close up some of the holes.
Yeah, I think you could probably just look at some of the other drafts that do similar capabilities.
Okay.
It all depends on how you want it scoped. I think you want it scoped at the ISIS level or OSPF area level is where the information is scoped, because that's where the multipath or the multipath is computed.
Yeah, that's probably right. Yeah.
Yeah.
Thanks.
Thanks.
Any other questions, comments? AC and Chris, do you have anything?
No.
I was just going to say this, speaking as working group chair, I think we want to discuss the power group draft. I mean, there's a couple of things that I think it makes sense to last call that we talked about, have requests for last calls, both the one presented and the one and Tony's. And the power group, we should do that right away while it's fresh on everybody's mind.
You mean adoption, right?
Yes, well, the adoption, and then hopefully the questions will ensue.
Yeah, I think we'll continue the discussion on the mailing list. There will.
Mhm.
Okay. If no more questions, I think we are done for this session. And we'll see you next time in Vienna. Thank you, everybody.
Bye, everyone. Thanks. Tony, you are like right next to the camera. I don't know if it's a hidden camera or. I can't believe we've ended early.
That's a first.
At least for a long, long time, it sure is.
Mhm.
Yeah, maybe never as LSR. That's a milestone. All right. See you guys later.
Okay. Yep. See you later.